This video is for class 8 physics, and in this video we are discussing the refraction of light through a rectangular glass block. Refraction of light through a rectangular glass block. So figure 5.11 shows a rectangular glass block PQRS right here. This figure here shows a rectangular glass block. So actually I want to explain the whole thing from here only, from particular this figure only. Here you can see one incident ray, okay, which strikes the surface of separation of a glass. So the light is moving from air to glass. So as you all know, when the light moves from air to glass, it should suffer refraction. Thus the ray of light, this is the refracted ray, will bend towards the normal. So hence this is my refracted ray. Again this refracted ray will try to come out from the surface of separation. Now the light is travelling from glass to air. So under this condition you will know that this particular ray will try to bend away from the normal. Now this ray, the third ray here, is known as the emergent ray. The third ray here, it is known as the emergent ray. Suppose the glass slab was not there, okay, so under that condition the light would have gone straight, okay. Now because of the glass slab, the emergent ray is being produced. Now as you can see, this ray, the incident ray, if it is produced forward, right, and this emergent ray are parallel to each other, right, they are parallel to each other, and but they have been separated by a distance. This is known as lateral displacement or shift, is known as shift like before, and or lateral displacement, since it is not fitting here, so I am writing it here. So lateral displacement. Let us try to draw this particular figure and you'll understand, okay. So let's see how it can be. So let us consider a glass slab, okay, sorry, alright. So this is a glass slab. So when a ray of light, okay, when a ray of light strikes the surface such that it makes some angle with the surface of the glass slab. Now the ray of light is moving from air to glass. Yes, so what should happen? It should bend here towards the normal. Since it is bending towards the normal, right, so we have created one angle of refraction here, and this is the angle of incidence. Now further, if I draw a normal at the point of incidence here, now this is my refracted ray, okay, refracted ray, okay, whereas this is my incident ray, right. So now again the ray wants to come out from the glass slab. While it is coming out, okay, while it is coming out, this the third ray is formed, which is known as emergent ray, and it also forms one angle E, known as angle of emergence, sorry, angle of emergence, NC, angle of emergence. So these are the few things about the refraction of a light through a glass slab, okay. For better understanding, I again made a clip, so you can watch the clip also. This clip was played in the earlier videos also, so I'd like you all to watch this particular clip again. Here you can see the incident ray, right, is hitting the glass slab, and you can see the bending of light also. So if there was no glass slab, here you can see the ray goes straight, right, the ray is going straight. Now once we are putting the glass slab, okay, now you can see the bending of the ray went here. So now third ray could not be seen, but if I shoot the ray in this way, there is no refraction, it is going straight, okay. So I hope this is clear, right, I hope this is clear. So coming back to the figure, here this particular X shows the lateral displacement, right? This is the lateral displacement. Okay, I hope this is clear. Let us go to the next topic, which is the refraction through a prism. But before going to the refraction of prism, we need to know what prism is. Okay, so prism is a transparent medium. It can be made out of plastic, it can be made out of glass, or any transparent medium bounded by 5 plane surfaces with a triangular cross section. Two opposite surfaces of a prism are identical and parallel triangles, while the other 3 surfaces are rectangular and inclined on each other, as shown in figure number 5.12. In the symbol form, it is represented by a triangle ABC. So simply I can represent a prism, right, with the help of a triangle ABC. So this particular surface here you can see at the back, and this particular in the front are parallel to each other. There are 2 parallel triangular surfaces, and there are 3 rectangles, that is 1, 2, and this particular rectangle here 3, this particular rectangle here 3. So I made a small clip of the prism also. To understand what prism is, let's watch that clip too. So this is a small clip of a prism. At this bottom part here, I think you can see some spectrum also, right? You can see some spectrum also. Okay, this we have to discuss in the dispersion of light. Okay, so let us play the clip and understand what prism is. So this is a prism. Okay, so here this is the triangular part. Okay, the other triangular part will be at the back, right? And we have 3 rectangles, 1, 2, and one more, right, at the back. Okay, at this back, at this surface here, let me mark it here. Okay, so 1 rectangle, 2 rectangle, sorry, 2 rectangle, the second rectangle, and here shall be the third one. Okay, and this is the first triangular part, and the bottom one here is the second triangular part, which should be parallel to each other. So I hope you have understood this particular what prism is. Coming to the part refraction of light through a prism. So figure 5.13 shows a prism ABC. A ray of light PQ of a single color falls obliquely on the face AB of a prism. This ray enters from air to glass, that is from rarer medium to the denser medium, so it bends towards the normal NQM to the face AB and travels along QR at the face AC of the prism. Another refraction occurs. The ray QR now enters from glass to air, that is from denser medium to the rarer medium, so it bends away from the normal N dash R M dash, so the face AC and travels along RS. Thus for the incident ray PQ, the refracted ray inside the prism is QR and the emergent ray outside the prism is RS. Thus on passing through a prism, the light ray bends towards the base of the prism. Okay, the light ray is bending towards the base of the prism. This is the diagram we are talking about in that particular paragraph. Here you can see the incident ray. Okay, this is the incident ray, strikes the surface of separation. Okay, so right now it is traveling from air to glass, so that it should bend towards the normal. Now a normal is drawn such that it makes 90 degree with the surface. Since it is bending towards the normal, hence the original position of light would have been gone straight, but now because of the refraction of light, you can see the bending too here, right? So this is the angle of refraction, this is the angle of incidence, right? So again this ray travels inside the glass slab, right, without bending because it is traveling the same medium. Then again it wants to come out from the glass to air. Now this time it is trying to bend away from the normal because it is traveling from the denser medium to the rarer medium. Thus it bends away from the normal, and this is the second normal drawn. So this is how the refraction of light is taking place through a prism. Let us understand this with the help of a small clip and few images. I'd like to show you one image where I was about to start the experiment. I'm keeping the laser light here, right, and you can see the image of the laser light has been shifted because of the prism when I'm looking the laser light from this particular face of the prism, right. So this is the angle of the prism here. Okay, so I was trying to do the experiment and you can see the image of the laser shifted. So this is a refraction of light. Here you can see the shifting of the image, right. So the other image which I would like to show you is this one, where when the torch is on, the laser light is on, as you can see some part of light ray here, traces of light ray. This is the incident ray. Okay, this is the incident ray. INCIDE INCIDENT, sorry, the spelling is mistake. Okay, the incident ray here, and here this ray coming out, this ray here, when it comes out, this ray here, when it comes out, it becomes the refracted ray. But this particular figure is not matching with your book figure, so for that purpose also I have taken the clip from the top part, from this angle, so that it will be easier for you to understand. Okay, this is from the side view. Okay, then we'll shall see from the top view as well. Here you can see this is the top view. Okay, this is the top view. The light should go from here, strikes the surface of the prism. Here should be the normal, the light should bend towards the normal. Okay, and again the other normal should be drawn here, and the light should bend away from the normal. This is the incident ray, this is the refracted ray, whereas this is the emergent ray, and the emergent ray is always facing the base of the prism. This is the base of the prism, this is from the top view, right. In your diagram just a triangle can be shown, right. In your diagram just a triangle can be shown. This is how the refraction can be shown in your exercise book. Okay, so let us watch the clip now for better understanding. Okay, before going to the clip, I would like to show you a picture taken during the experiment. Okay, here you can see a light ray. Okay, a light ray from the laser light strikes the prism. This is the refracted ray inside the prism, and since the laser was so powerful, the emergent ray is not able to seen properly because it has been blurred on the paper here, right. Okay, let's see the clip. Probably in the clip you might find it out. Okay, here is a clip, right. Please watch the clip. So this is the incident ray here. Okay, which going straight, and then we have refracted ray, and right now I think so you are able to see the emergent ray also. If the ray of light is hitting from the top, then what happens is the ray is not coming out. You see the emergent ray here, the emergent ray always comes from the bottom. So this much for this particular video. Thank you so much.